Hi everyone, welcome back to Dave's Math channel. I'm your host David Tare, and today I'm going to do my fifth video on my sub-series on derivatives of my series on first year calculus. And today we're going to talk about another important differentiation rule, namely the quotient rule, which tells you how to take the derivative of a quotient of two univariate functions. And here it is written out. So anyway, let's begin. So let's first state again what the quotient rule says. And I'm going to use a little different notation for my functions. I'm calling them u of x and v of x here. I think this is the usual notation. Just remember that u and v are just other names for functions. And I like to use u for the numerator and v for the denominator. It seems to be a pretty common convention. So here's what the quotient rule says. It says that if you have the derivative of a quotient of two univariate functions, u of x over v of x, that the derivative of that quotient is equal to this expression here. It's a pretty complicated expression, but it has the numerator has kind of the same form as the product rule. There's just a couple differences here. So let me just say what it says. It says that the numerator is equal to v of x, that's the denominator, times u prime of x, that's the derivative of the numerator, minus u of x, that's the numerator, times v prime of x, that's the derivative of the denominator. So remember that with Leibniz rule, the product rule, you had I think you had f of x, g prime of x, plus g of x, f prime of x. It has sort of that same kind of form. But you have to remember which one goes first. The denominator always goes first. So denominator times derivative numerator minus numerator times derivative denominator. Remember that. That's the first thing you have to remember for the numerator of the derivative of the quotient. And then finally, denominator, that's easier. That's just the square of the denominator of the thing you're differentiating. So you have v of x squared in the denominator. That is the statement of the quotient rule. And I know it's a little complicated. This is something I think you should memorize. But I'm going to derive it. And in order to derive it, first we're going to derive a simpler rule. And this is actually a special case of the quotient rule. I call this one the reciprocal rule. So what if we just want to take the derivative, the reciprocal of a function? This is a special case where u of x is 1. So what if we just want to differentiate 1 over v of x, where v is a differentiable univariate function? Well, here's the formula for it. This is a much simpler formula. It's just minus v prime of x over v of x quantity squared. That's a lot easier to remember. And anyway, so what we're going to do here is we're going to first derive the reciprocal rule, and then we're going to use that result to derive the quotient rule. So here's the proof. So like I said, there's two parts to this proof. The first part of the proof, we're just going to derive the reciprocal. And that's the first thing I do here. And the way we do that, we start with this product v times 1 over v. And that's just equal to 1, trivially. I mean, that's pretty obvious to see. If you multiply any quantity by its reciprocal, you always get 1 by definition. So if you take the derivative, and you guys should know this. Maybe I should have pointed this out earlier. Special case of the power rule says the derivative of 1 is 0. Remember, 1 is just x to the 0. And then using the power rule, that would be 0 times x to the minus 1. Well, the 0 makes it 0, because if you multiply anything by 0, you get 0. And a more general rule, which I probably should have said already, the derivative of any constant is always equal to 0. I mean, that's pretty obvious, right? Because derivative just measures the slope of a function, and a constant, if you draw it as a function, it's a horizontal line. You know, y equals c, where c is a constant. That's a horizontal line of height c in the xy plane. And since it's horizontal, its slope is 0, which means its derivative is 0 everywhere. So in particular, the derivative of 1 is 0. 1 is a constant. So that's what we start with. So we say 0 is equal. Now, notice that this thing v times 1 over v is a product. Okay, and we already know the product. So we can do a little trick here. We can write 0. We can also use the product rule to calculate the derivative of v times 1 over v. And if you do that, you get, first you get the derivative of v, that's dv dx. We're using Leibniz's notation here, times 1 over v. And then we take v times the derivative of 1 over v. And that's what we want to find, the derivative of 1 over v. But we know this sum has to be 0, because we just said this product was 1. So now we can just bring the ddx of 1 over v to the other side. When you do that, you get ddx of 1 over v is minus the first term, minus 1 over v squared times dv. It's minus dv dx over v squared, or minus v prime over v squared, if you like. So we just derived the reciprocal. Remember what I said? The derivative of 1 over v of x is v prime of x over v squared. Here we're using Newton's notation. Here we're using Leibniz's notation. Really, you just say the same thing. So we just derive the reciprocal rule. Now, finally, we're going to use the product rule one more time. Because now we can think of u over v as u times 1 over v. So now we can apply the product rule to that. And let's just do that. So, we start by taking, yeah, well, they think they did things kind of backwards here. You get, oh no, they did it right. Du dx times 1 over v plus u times the derivative of 1 over v, which we already said was minus dv dx over v squared. We bring everything, how does this work? We already know what, okay, yeah. So now we have u prime over v plus u minus uv prime over v squared. We just bring everything over a common denominator. The common denominator is v squared, so we have to multiply the first thing by the numerator and denominator, the first expression by v, so then you're going to get v du dx, that's just the first term, minus u dv dx, that's the numerator, and the denominator is v squared. Voila. That's the proof. That is the proof of the quotient rule. Kind of a complicated proof, but at least now you see how to prove it. And anyway, that concludes my video. That's the proof of the quotient rule, which is a very useful rule in calculus. So that concludes my video. Thank you for watching. Long live math, and I'll see you guys next time. Bye.